me brief what we have done in organic chemistry. We have done only 3 classes of the organic, right? In the first class, we show the inductive effect. What are plus I and minus I groups? I have recording of that. If anyone of you want the recording of inductive, you can take it from me. And then there is resonance. So resonance, like you have also seen in your classes, like this is the simple thing where we see the delocalization of pi electron in the conjugated system. What do we mean by conjugated system? Basically, we are having pi sigma pi bond and pi sigma atom having lone pair. Like we are having these kind of cases, lone pair, and then the next is there is double bond. In that case, there will be resonance happening, and negative charge is there, then there also resonance will happen. Positive charge is there also resonance will happen. And then pi sigma pi. In that case, where we have to move the pi bond, that we can see where the positive charge is present. Actually, the electron movement will take place from high electron density to low electron density. So here the carbon is having partial positive charge. So electron will move from this pi bond towards this C double bond, right? Because it is having positive charge. Why it is having positive charge? Because the oxygen is more electronegative. So Siddharth, are you comfortable in this in making the resonating structures?
No, sir, not yet.
Not yet. So can we do, because we haven't done, still we haven't done the resonating structures making, because in one time there was a question in the JEE Advanced, how many resonating structure will be there in the given molecule. So first let us be comfortable in drawing the resonating structures, okay? So that we do not get any, because when we are able to draw the RS, then we will be able to do the other things also. Like, because we have to compare the stability of resonating structures, so that we will be able to do. We have to see the we can say stability of intermediates like carbocation, carbon. So for that purpose, we need to be comfortable in drawing the RS. And we haven't done enough work in this thing, right? In the previous class, we haven't done. Because of your exams, like we did this topic quite early, but now we will be giving some enough time to draw the RS, right? So let me just revise the cases of resonance. Okay. So first, what we are having, like this is a double bond and the atom having lone pair. So this lone pair, actually it is a pair of electron which will be present in the p orbital, right? And you know better, like pi bond forms between the p and p orbital, right? Suppose this is a pi bond. So pi bond is formed by pp overlapping. Now this is a lone pair. So this lone pair will get transferred here, right? Why it is transferring? Because this p orbital and this p orbital, they can also make a bond, right? Because the overlapping can happen here also. That is why we are calling it conjugated system. What do we mean by conjugated system? When there are continuous p or d orbital are present, p or d orbital, continuous p or d orbital are present, then that system is called conjugated. And delocalization of pi electron, like we can see in the resonance what happens, electron moves continuously. Like very famous example in benzene. In benzene, you all know, like benzene looks like this, right? Benzene looks like this. So these 3 pi bonds are there. So these 3 pi bonds are formed by p and p orbital overlapping, right? Because sigma bonds are formed by hybrid orbitals and pi bonds are formed by pure p orbitals. This thing we will see in chemical bonding chapter. So here 3 pi bonds are made like that, right? But in the resonating structures, in the resonance, when benzene will be having resonance, so suppose pi bond is formed between these 2 orbitals. So pi bond can be formed between these 2 orbitals also here. Because if these orbitals can overlap, so these orbitals can also overlap. So that is the case of the resonance, when the other p orbitals do the overlapping and make another pi bond, right? So this time we are having a pi bond here and here and here. So you can see the electrons are continuously moving. These 2 are the resonating structures. But what will be the actual scenario? Actual scenario or actual existing form of benzene is none of them. The actual existing scenario or the structure of benzene is this one, when there will be continuous movement of the electrons in the benzene, right? Because beta, like you just see the example what I am giving you now, that a fan is there, right? A fan is there, and fan is stopped, suppose. So you can see the three wings of the fan clearly, but when it moves continuously, you will see wings are everywhere, right? We cannot even count the wings, and we see wings everywhere. In the same way, when resonance happens, so you cannot see the three pi bonds, you will see pi electron density everywhere, right? You will see the pi electron density everywhere throughout the p orbitals. And this resonance happens because of some energy, right? As the fan starts working when we give the electricity, similarly this pi electron movement happens when we give some energy, and that energy is available at room temperature. So if that energy is available at room temperature, that means resonance will always happen. Resonance will always be happening. So these are not the existing form of benzene. Benzene exists in this form where pi electron continuously move throughout the ring. Tell me, did you understand this thing?
Yes, sir.
Everyone, please.
Yes, sir.
So resonating structures are imaginary, resonance hybrid is real. Which is resonating structures? Whatever we draw are the resonating structures only. This is resonating structure 1, this is resonating structure 2. And what is this beta? This is resonance hybrid. Hybrid is the one which is made from the structures, right? So this is the resonance hybrid. So resonance hybrid is real. This is real. This exists, but these are imaginary. Okay, these are imaginary. So this thing we knew now. Now what we are going to do, we are going to draw the RS, resonating structures. Let us draw the resonating structures. Drawing. Drawing resonating structures. So I am taking first, like we will do case by case, okay? ST. Because beta, like I know the benefits of drawing the resonating structure. That's why I'm giving some enough time on this topic. See, first case we are taking double bond with positive charge, double bond with lone pair, double bond with lone pair. So many things I'll be telling you here. You please listen it very carefully. See, suppose you are having CH2 double bond CH and then OH is there. So oxygen is having 6 valence electron, right? You know that oxygen is having 6 valence electron because the atomic number of oxygen is 8, because 2 electrons are present in first cell, 1s2. So the remaining 6 electrons are present in the second cell, 2s2, 2p4. So the electrons which are present in the outermost cell are the valence electrons. So we can say these oxygen is having two pair of electrons. So what are these? These are the lone pairs. So now, if I ask you what is the hybridization of oxygen here in the second case, so how do we find the hybridization? Actually, we haven't done the topic in the, because we will be doing that in chemical bonding, but still. You are also doing these things in your school and like in your other institutes. So you can tell me what is the hybridization of this oxygen? Can you tell me? Everyone?
For sp3.
Others? Siddharth?
sp3, sir.
Okay. And Siddharth, what do you say?
No, I don't know, sir.
Okay, no problem. Afik?
No, even I don't know, sir.
Okay, no problem. Because we haven't done this thing, so we will be doing these things, no issues at all. Right? but like because currently we need this, so I'm giving you a brief about like how to find the hybridization. What we do to find the hybridization, we count the lone pair plus sigma bonds. Sorry, lone pair plus sigma bonds. An atom, for an atom, you have to count the lone pair and you have to count the sigma bonds, and then that case will be giving you the number of hybrid orbitals. See, this oxygen, how many bond it has made? One bond with carbon and one bond with hydrogen. So number of sigma bond is 2 plus lone pair. How many lone pair are there? 2. So it is coming, the sum is coming as 4. 4 means 4 orbitals. So one orbital will be S and other 3 orbitals will be P. So the hybridization will be sp3. No problem. Like you just do not know the meaning of the what is hybridization, sir, what is the actual meaning, significance we are not understanding. No problem. We will do that in very detail. But for now, you just see this oxygen is sp3 hybridized. Okay, fine. But like this oxygen, this oxygen is not sp3. It is again having 2 sigma bonds and 2 lone pair, but this is not sp3 hybridized. Why, sir? Isn't it following that thing? Like the way to find the hybridization is not same for this. Actually, what happens? This lone pair can undergo resonance. This lone pair can do the resonance. This cannot do the resonance. Why? Why, sir? It cannot do, because this is attached with the sp3 carbon atom. So when the why? What is the meaning of resonance? You just see. Suppose a pi bond which is already formed. Now, a pair of electrons is present in the p orbital, then there also overlapping can happen, right? Pi bond is formed by pure orbitals overlapping. So if already a pi bond is there, then overlapping because can happen here also. That is why movement of lone pair takes place, right? This is called resonance. But here, it is not having, this carbon is not having a p orbital beta, because this carbon has made 4 bonds. That is why it is having sp3 hybridization. So it is not having a orbital like that. It is not having. What is this orbital? This is p orbital. But all the p orbital are used in the hybridization. So this carbon is not having any p orbital. That is why these lone pair cannot move here. If they cannot move here, that means they cannot participate in resonance. But this lone pair can participate in resonance. That is why this is present in pure p orbital. This is present in pure p orbital, because when it is present in p orbital, only in that case it can do the resonance. Okay, a lone pair can do the resonance when it is present in p orbital. So if one lone pair has used a p orbital completely, now there are how many p orbitals? 3. So one p orbital is used by this lone pair. How many are remaining now? 2. That means this oxygen is not sp3, it is actually sp2 hybridized. This is sp2 hybridized because one lone pair is utilized by the one p orbital is utilized by the lone pair. So this oxygen is not having 3 p orbital for hybridization. It is having only the left 2 p orbital for the hybridization. That is why we can say that it is not sp3 hybridized, it is sp2 hybridized. So when you see the difference, so I'm making the things easier now. When there is no resonance, you just count in that way. When you are having the resonance, so if you are getting answer as sp3, you just do -1. That means sp2 is the answer. When there is resonance, you just do -1. sp2 is the answer. Okay, tell me, did you get it?
For every case?
Huh? Hello?
Hello?
Yes.
So is it for every case or only this case?
No, it is for every case. Whenever you are having a lone pair, suppose I am taking another example, NH2. This nitrogen, and let us take another nitrogen, CS3NH2. Let us take this one. So you can see this nitrogen is having 3 sigma bond plus 1 lone pair. So it is coming as 4. Sum is coming as 4. 4 means sp3. So that is sp3. But this lone pair can participate in hybridization. Sorry, in resonance. So that means it is present in p orbital. But so now the nitrogen is having only 2 p orbitals left. So it is having again sp2 hybridization rather than sp3. Got it?
Sir,
Yes.
I understand the part where you said one p orbital is being used, so it would have a hybridization of sp2. I didn't understand. Can you repeat it again?
Okay. See, beta. Suppose this carbon, this oxygen configuration is 1s2, 2s2, 2p4. This is the valence cell. In the valence cell, you can write the electronic configuration in that way, right? Okay. So if this p orbital, like this p orbital is used in making the pi bond, this is making pi bond. So hybridization is mixing of orbital. So you are having only 3 orbitals left for mixing. So hybridization can be sp2 only, no?
Yes.
Hybridization can be sp2. Hybridization cannot be sp3 because this p orbital is not available for hybridization. It is involved in the resonance, right? But in this case, as it is not having a resonance, so this can be involved in the hybridization. That is why it is sp3. So what is the case? When you are having a lone pair which is participating in resonance, then the hybridization which is coming, you do just -1, sp2 is the answer. And when there is a not resonance, so you just do simply lone pair plus sigma bonds. That is the answer. And when the lone pair will participate in resonance, the lone pair will participate in resonance when it is next to double bond, right? When it is next to double bond, then it will participate in resonance. I hope you understood it now.
Yes, sir.
Everyone, Siddharth,
Yes, sir.
Afik?
Yes, sir.
Okay. Fine. So now we will see how to draw the resonating structures. Okay. I am having one case. Let us take this one. OH. So beta, this is a lone pair. Always the resonance, when lone pair is there, always the resonance will take place from the lone pair. So see, these electrons are coming here. That means a pi bond will form here, but this existing pi bond will break because this carbon has already made how many bonds? 4. It cannot make the 5th bond. So but it is making the another bond. So it has to break the other existing bond, right? So how to draw the RS? This pi bond will be as it is, but this will shift. As these electrons are coming here, the existing pi bond will be shifting on the other carbon atom, next carbon atom. So this will be having a negative charge. As the electrons has came on this atom, then here double bond is formed. Oxygen, as oxygen has donated the electron, that is why it will be having a positive charge. Right. Now what to do? Now this negative charge has came. So now you can shift this negative charge here, and again this pi bond which is made by 2 electrons, you can shift these pi bond to the next atom, right? We have to shift the pi bond to the next atom. Here pi bond will form, here double bond OH positive, and this will be having again a negative charge. So these are the resonating structures. How many resonating structures are there? 1, and then 2, and then 3. But you know that these are not the forms of the molecule which are existing. Existing form is the hybrid. How to make the hybrid? You can see pi bond is here, pi bond is here also, pi bond is here also, pi bond is here also. So pi bond is everywhere. So we will show the pi bond like that. You just remember the example of fan. What we did the same thing, right? So oxygen is having positive charge in the resonating structures. This is having negative charge, this is having negative charge. So this is resonance hybrid. Like always the pi electron will be moving, na beta, because there are continuous p orbitals. So continuous, regularly there will be the movement of pi electrons. This is what the meaning of resonance is. But we should know how to draw the resonating structures also. So did you understand this?
So can you explain the third one, the resonating structure?
This one, right?
Yes, sir.
So this negative charge, what is the meaning of negative charge? Negative charge is a pair of electron only. Like you can see, this particular bond is shifted on this atom. So this was a pair of electron only. Like this bond is made by a pair of electron. So this electron pair is shifted on this atom, right? One electron was belonging to this atom only, but one extra electron has came on this atom. That is why it is having a negative charge. But this negative charge is means a pair of electrons. So this is a kind of lone pair only. So whenever the lone pair is there, we shift the lone pair to the next sigma bond, and then we break the other next pi bond on the next atom. In that way, we did the same thing, right? So negative charge is coming here. Now this atom will become neutral. Why neutral, sir? Because this has donated the electron. As oxygen has donated the electron, it was neutral, so it gain a positive charge. Now this negative charge atom is donating the electron. So when negatives will donate, it will become neutral, right? And this pi electron will again shift on the next atom. It will having a negative charge. In all the cases, you will find that resonating structures are having same charge. It was neutral, it is neutral, it is neutral. All are neutrals only. Like the charge cannot be created. The charge cannot be created. So the resonating structure, whenever you see, suppose this molecule was not having any charge, but in the resonating structure, you see a net charge, either positive or negative, then that RS is wrong, right? Because the molecule does not have a charge. How the resonating structure can have a charge, right? It won't have the charge. So did you understand now?
So it will be always neutral.
If the molecule is neutral, then the resonating structure is neutral. But if the molecule is charged molecule can also be there. Suppose we are having this one. That molecule is charged. This one. Yes, this one. Here in this case, this molecule is having one negative charge. So in all the resonating structure, you will find one negative charge as the net charge. In all the resonating structure, you will find negative charge as the net charge, right? So if the molecule is having a net charge as 1 minus, in the resonating structure, you will be having the same charge. If the resonating structure is having 1 plus, then all the RS will be having 1 plus only. Like the same charge. Charge will not vary. That is the thing. Now, did you understand this thing?
Yes, sir.
Will you try now another question? You have to try now. By yourself, pen and paper, you have to draw the RS of this one. Everyone has to draw the RS of this one. This is phenol, right? When OH group is attached to benzene, then that is called phenol. How will you proceed? From lone pair, you will shift the lone pair to the next sigma bond, and the other next pi bond you will break. Try. You can take help from the resonating structures which I have drawn. Okay, done. One RS, one resonating structure have you drawn? One? At least one?
Yes.
Yes, sir.
So like we will be moving this lone pair on this sigma bond, and the existing pi bond we have to break. So the resonating structures look like double bond OH plus, right? Double bond will form, oxygen will get a positive charge. This carbon will have a negative charge, and this is the resonating structure. So how many of you have drawn this resonating structure? You can raise your hand.
So how did the double bond come to OH? Like,
Yes, because it is donating the lone pair, na? That is a pair of electron, and a pair of electron can make a bond. This pair of electron will shift here. You will be having a formation of bond beta.
okay, so got it. I made a mistake in double bond.
Okay, but now did you get?
Yes, I got it.
Okay, so now what to do? We have to make another RS. So we will shift this existing negative charge here, and the existing pi bond we will break in this way. So what we will be getting? Double bond OH plus here a pi bond, negative charge. Now what will happen? This negative charge will shift here again, and this pi bond will break in this way. So like whenever you will be able to learn it, no, it will become super easy for you. Negative charge, double bond OH plus. Now what to do? You just shift this negative charge here, and then existing pi bond will break. So now what will happen? You will be having a pi bond here, double bond, OH. It will become neutral because the oxygen is accepting the electron, so it will become neutral. So did you understand drawing RS in this case?
Yes, sir.
Ovia, Afik?
Yes.
Yes, sir.
But you have to give me confirmation here every time whenever I ask. Anirudh.
Yes, sir.
Okay. So now you have to try this one by yourself. You have to try this one. Benzene is there, O is there, but you are having negative charge this time. So negative charge will move just like the lone pair. Negative charge will move. Try making this one. But as it was already negatively charged, so when it will donate the electron, it will become neutral, not positively charged. Okay, so how to do that? We will make this negative charge here. Existing pi bond will break. So the resonating structure looks like this. Double bond O will become, and you will be having a negative charge here. Double bond. So this will be coming here. This will be going here. So now it will look like double bond, negative charge, again double bond O. This negative charge will go again here. This existing pi bond will break. So how to do that? Double bond, negative charge, double bond O. And now this negative charge will come here. This will go again to the oxygen. So it will be like that. Okay. So how many of you were able to draw all the RS correctly? Anirudh?
Yes, sir.
Afik?
Yes, sir.
Ovia?
No, sir.
Siddharth?
Sir, I understood now. But I was
Okay. Yes, like what happens when we draw now, like beta, like just when we start learning riding bicycle, we do so many mistakes. But when we learn it, it becomes super easy. The same thing applies here. It seems difficult, but when you will be solving again and again so many questions, it will become very easy. Let us take next one. Okay, so now we are taking this one. Negative charge here. Let us do the RS here. Let us draw the RS in this case. This negative charge can go in the left side and can go in the right side. So you draw both. One time you make it, one time you just, the negative charge, you just send it on the left side. Then the second case, you just send it on the right side. Both will be the RS. The negative charge, suppose if I take it on the left, it will be having a bond here. The existing pi bond will break and the negative charge will come here. So it looks like negative here, double bond here, and double bond here, like that, right? But as the negative charge can go on the right side also, so we will make it on the right side. So we will have a resonating structure like that. The left pi bond as it is, and there will be a double bond, and there will be a negative charge, and this one. This is the RS1, and this is the RS2. Got it?
Yes, sir.
Was it same for all of you?
Yes, sir.
Siddharth? Siddharth,
Yes, sir.
have you made it correct?
Yeah, got it, sir.
Okay, this one. You draw for this one. Then the sixth one you have to draw. And after sixth one, I'll be giving you the JEE advanced question. Okay, so in the fifth one, it is very easy. Like what will happen? This negative charge will go here and this existing pi bond will break. So you will be having the RSH O minus, then double bond O. Got it, no?
Yes, sir.
Yes, sir.
Like same, did you make same only?
Yes, sir.
Yes,
So
sir.
these are two RS, but how does this look like? Resonance hybrid. In the resonance hybrid, you will be having pi bond everywhere, right? You will be having pi bond everywhere because this pi bond is here only, here also, and this pi bond is here also. But in reality, it will be continuously moving, right? There will be continuously movement. So we show that by the dots, okay? And the oxygen is having the negative charge in the resonating structures. So we will be showing the partial negative charge because total one negative is there. So if you see one negative on both, then it will be represented as two negative. So let us just divide this negative charge on two oxygen atom. So we will be having this. And we can actually tell also that this negative charge, oxygen is having minus half because total negative charge is -1. But on two oxygen, it will be minus half and minus half. This is what? This is resonance hybrid. Okay, you try the sixth one now. Sixth one, it is just like the third one, but you do not have to see. Try the sixth one now. It is just practice only. Sixth one. Okay, are you able to draw?
Yes, sir.
Yes, sir.
I think the first one you have draw like that. This negative charge will come here. This bond will shift here, and you will see the resulting structure like that. Double bond CH2, negative charge will come here. Double bond, double bond. Then what will happen? This negative charge will shift on the next sigma bond, and this existing pi bond will break. And we will see the resulting structure as double bond, negative charge, double bond CH2. Then what will happen? This negative charge will come here and this pi bond will break like that. So we will see the resonating structure as double bond, negative charge, double bond CH2. Then what will happen? This negative charge will come here. This existing pi bond will break. So you will be getting the resonating structure as this one, CH2 minus. So now you tell me, did you get it?
Yes, sir.
Yes, sir.
Yes, sir.
Siddharth?
Yes, sir.
Okay, fine. So now what I wanted to ask actually, this is the resonating structure 1, this is 2, this is 3, this is 4, this is 5. So 1 and 5, are they different or the same? 1 and 5. They are different resonating structures or they are same only?
Different, sir.
Different, yes, because the position of pi bond is different in the both cases. So like it is the case, in resonance what happens, the position of pi electron changes only, molecule will be same only na yaar. What we are doing in the resonance, we are just shifting or we are just moving the pi electrons. So in the resonance what will happen, the number of pi bond will be same, the charge will be same, but the thing is they will be just on different atoms, right? This is the meaning of resonance. Movement of pi electron and charge is called resonance, right? So this is what is happening. So these are the different resonating structures. So if anyone asks you how many resonating structures will be drawn, so answer will be 5. But hybrid will always be 1. And how we can show the hybrid? In the hybrid, the pi bond is moving throughout the ring, so it will look like that. CH2, here also the pi bond is moved. So negative charge was there. So negative charge we have to draw on the atoms on which it has been in the resonating structures. Okay, so now I think we are able to do this one. 7th, you have to try this one now. You have to apply the knowledge what we have understood till now, and you have to draw the resonating structures. How many resonating structures are possible in this compound? Okay, try. If negative charge can go on both side, then you have to take it on both side, step by step. Okay, done. How many RS you are getting? How much you have drawn so far?
Sir, I got 6.
6. Okay. Others?
Sir,
Yes.
sir, I'm not getting how to do it, sir. Can you do it?
Yeah, I can do it, but didn't you make any RS?
No, sir, I don't know where to put the negative charge.
Sir, I got 9 now.
Who got 9?
I got 9.
Afik.
So I got 5.
Siddharth got
Sir,
9.
even I got 5.
Siddharth got 9. Okay. And Anirudh got 5. Afik, you got 5 also.
Yes, sir.
Ovia didn't get any. Let us see how to do this. Beta, Ovia, where you are getting confused? Like this negative charge, you have to shift on the next sigma bond, right? Next single bond. And just next the pi bond is there. You have to shift it on the next atom. Okay. So how does it look like? The left side ring will be as it is. And you will be having double bond O, negative charge, and again double bond. Yes. Now this negative charge will go here on the next sigma bond. Just next pi bond will go onto the next carbon. Okay, it will go onto the next carbon atom. So how will it will look like? Again benzene, then double bond here, negative charge here, double bond. Now what will happen? This will go here, and the next pi bond you just shift on through the next atom. Like sometimes students are confused like where we have to shift the negative charge. So the pi bond you are breaking now, you just shift onto this onto the next atom. So now it will look like this: pi bond, double bond O, negative charge, pi bond, right? Now here just wait for some moment. You can see this negative charge can go to the right side, and this negative charge can go to the left side also. It can go on the both the sides. Okay, let us make it on the right side. If we make it on the right side, then we will be having the resonating structure as this one, this one, this one. Other bonds will be as it is. Double bond will come here, but this existing pi bond will break and the negative charge will come on the oxygen atom, this one. Okay, but this negative charge can also go on the left side. So now let us make it on the left side. The pi bond will break. So we will be having the resonating structure like other pi bonds will be as it is. Negative charge here, double bond, and this will be double bond over. Now what will happen? This negative charge will again shift here. This pi bond will break here like that. So we will be having the resonating structure as negative charge, double bond, double bond, double bond, double bond, double bond. Now what we can do? We can just shift it here. You have to stop when you are getting the same RS. Till then you just go. You just draw the RS. Keep drawing the RS. Double bond will come here, negative charge here, double bond. You can see, is it repeated? So you can see this matches with this one, but this is not exactly same. This is not exactly same, right? So now what we'll do? We will still do the resonance. We will do it here. Then we will break this bond and we will be having this as RS. Double bond, double bond, double bond, and double bond, negative charge, double bond O. Again, what we will be doing it here and there. Then we will be having the RSH, double bond, and then double bond, O negative. So you can see none of the RS is completely matching with the other one, right? You can see this one and this one, they are different beta. They are different. All in both the cases it is O negative, but the position of pi electron is different. And this one is also different. You can see this one and this one, all three are different only, right? So how many are we have found? 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. So one of the RS is still having the similarity. You can see which is having the similarity. I think all are different, or some one is matched with the other one. See, when you are having the negative charge on oxygen, and oxygen, so all these three are different. All these three are, yes, these three are different. Now let us see when the negative charge is here. The negative charge is here in this case, but these two are also different. Yes. When the negative charge is here, this matches with this one. But these two are also different. These two are also different, you can see. And when the negative charge is here, this type of RS you are having only one. When the negative charge is here, this is also you are having one. When the negative charge is here, so this is also the one RS. So yes, total answer will be 10. Answer will be 10 only. Total RS will be 10. Did you understand now?
Yes, sir.
Yes, sir.
So when do we stop?
We have to stop when the RS starts same. Like now, if we continue, if we still do this way, so now you will be getting the same thing. You can see it will match with this one.
Okay.
It will match with which one? This one. It will match. It will start matching with the other one, right? Okay. So now for my satisfaction, you have to do one more. Eighth one. You have to draw this one. O negative. Yes. We are having different position of O negative now, but like you have to draw it. How much you have drawn?
Sir, I'm able to get only 5.
5 only.
Yeah. Yes, sir.
You are also getting 5.
So you'll get 10 again, right?
No, it is not necessary. Just take some more time. Ovia, this time are you able to draw?
Yes, sir, I drew 4, sir.
4 only.
Sir, only 4.
Afik?
So still drawing, so.
Better try this one, yaar. Like, I think what mistake you have done, the negative charge when it will be coming here, no? Negative charge here, yes. The negative charge when it will be coming here. So it can go on both the side. It can go on the left as well as on the right. So you have to draw for them separately.
So could you do this?
Yeah, I will to do this for sure, but so how much you are getting, all of you? Final
I got
answers?
8.
8. Okay. Afik?
Even I got 8.
Okay. Ovia?
Sir, I got 7.
7. Okay. So let us see. First, I have to draw this one. Then we will be, oh, sorry. Which pi bond will break? This one, right? So this time, have you broken this pi bond only, no?
Yes, sir.
Yes. So now what will happen? This negative charge will go here and this pi bond will break. So we will be having negative charge here. Double bond, and double bond, O. So, but you will be having a double bond here, right? Now, the negative charge has come here, and from this point you can go on the left side and can go on the right side. Both will be different cases. First, I am drawing when we are going on the right side. So here, and this will go here. So we will be getting the RS, this one, double bond. Other bond will be remaining as it is. Negative charge will come here. This negative charge can again move here and double bond can move here. So the students who have got 7 now, they haven't considered these two RS actually. O negative, right? These two RS you haven't considered. Yes. Now, if we move from to the left side, then we will be getting this one, negative charge here. Other bond will be remaining as it is. Now we can again move this one. We can move this pi bond. So we will be getting double bond, negative charge, double bond, O. Then again negative charge will go here and double bond will go here. So we will see how bad the benzene is. Double bond, negative charge here, double bond, O. Final RS will be like this. So double bond and then double bond. Yes. So these are the RS you will be having. You can see none of the RS is matching with the another one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 was the answer of this question. This was the JEE Advanced 2015 question, and the answer is 9. So you can see better, this is not the very hard. Like, you just need some practice. Are you able to understand?
Yes, sir.
Yes, sir.
Everyone like at least understood. Did you
Yes.
understand now?
Yes.
Ovia,
Yes, sir.
I think you have missed these two RS, no? Like most of you.
Yes, sir.
You can make the negative charge to the right side also and to the left side also. So both you have to consider. So I can give you a homework now. So in the 9th one, let us take a hard one. You have to draw the RS for now. For this. In the homework, you have to draw RS for this. Okay. Yes. So you draw it and tomorrow we will discuss the answer.